Associative binary operation. Let the set K be closed under the binary operation, which have the symbol if for all AB, which ABC, which is an element of K, this equation is true. The equation is A operation B into operation C is equals to A operation into B operation C. Now when this equation is said to be true, then the operation is said to be associative. So if this hold for that given operation, then it is associative. And let's consider an example. We are going to investigate whether or not the operation defined by the relation below is associative. Now what is the relation? The relation is A operation B is the maximum of A and B. Now let us investigate whether or not this operation is associative. Now recall that for an operation to be associative, then A operation B into C should be equals to A operation into B operation C. If this is true, then this is associative. So we have A, B, and C. What can we do about it? Let's solve for this part of the equation. Then we'll also solve for this part of the equation. Now if both are equal, then it's associative. But if both are not equal, then it is not associative. So we're going to solve for A operation B into C. And to do this, we'll also choose a random value for A, B, and C. Now let A be 1, B equals to 3, and C be equals to 5. For this part of the equation, we have A operation B into C should be equal to 1, A is 1, operation 3, B is 3, into 5, because C is 5. Now we have 1 operation 3. 1 operation 3, according to the formula, is the maximum of 1 and 3 into 5. So this 1 operation 3 is the maximum of 1 and 3 into 5, using the formula that A operation B is maximum of A and B. So solving with this, the maximum of 1 and 3, which one is the highest number? 3 operation 5. So we are now in 3 operation 5. Now 3 operation 5, using the above relation, is the maximum of 3 and 5. Now what is the maximum of 3 and 5? 5. Hence, A operation B into C is equals to 5. Now, this part of the equation is 5. We also need to solve for this part of the equation. So let's solve for the other part of the equation. In the other part of the equation, we have A operation into B operation C. So this gives us 1 operation into 3 operation 5. So this 1 operation, let's solve for 3 operation 5. 3 operation 5 is the maximum of 3 and 5 equals to 1 operation. What is the maximum of 3 and 5? It's 5. So we have 1 operation 5, and 1 operation 5 is the maximum of 1 and 5. Now the maximum of 1 and 5 is 5. Now, since A operation B into operation C is equals to 5, and A operation into B operation C is also equals to 5. Hence, A operation B operation C is equals to A operation B operation C. They are both 5, so they are equal. Thus, the relation is associative. The relation is associative because we solve for both sides of the equation. We solve for this side of the equation, we also solve for the other side of the equation, and both are, this part is 5, this other part is 5, hence they are said to be associative. Now let's solve another example. Now we're going to investigate to show whether or not the operation defined by the relation below, we're going to show whether or not the operation defined by the relation below is associative. And what is the relation? The relation is P operation Q is equals to the difference between P and Q square all over P plus Q. Now we're going to show whether this operation is associative. So to solve this, recall that a relation has to be associative when P operation Q into operation R is the same as P operation Q operation R. Now when this condition is said to be true, then it is associative. So now let's use the value for P, Q, and R. To use the value of P, Q, and R, let P be equals to 4, Q be equals to 2, and R be equals to 3. So we're going to solve for this part of the equation. We'll also solve for this part of the equation, and if they are the same, then it is associative. So for the first part, P operation Q into R. So P is 4 operation. This is 4 operation Q is 2 into operation R, and R is 3. Now using the relation above, 4 operation 2 will be 4 minus 2 all square all over 4 plus 2. Using this relation here, then we'll also have operation 3. Okay, now 4 minus 2 is 2. 4 minus 2 is 2, 2 squared all over 6 operation 3. Now if we solve this, this is 4 over 6 operation 3. Now 4 over 6 is 7 times 2 over 3. When we divide both sides by 2, operation 3. So this is what we have right now. We are in 2 over 3 operation 3. So using the same relation above, we have that 2 over 3 operation 3 will give us 2 over 3 minus 3 all square all over 2 over 3 plus 3. I want to believe that we are good with fraction, so we can easily solve this out. Now 2 over 3 minus 3. Okay, let's use the basic method to solve it. This will be all over 1. The LCM of 3 and 1. The LCM of 3 and 1 should be 3. Now 3 into 3 is 1. 1 times 2 is 2. Minus 1 into 3 is 3. 3 times 3 is 9. All over. So we have simplified this top part of it. This bracket raised to power 2. Now the down part. Now this is not Q. This should be 3. Sorry about that. 2 over 3 plus 3 should be 3. So the same way, this is all over 1. The LCM of 3 and 1 should be 3. 3 into 3 is 1. 1 times 2 is 2. Plus 1 into 3, 3, 3 into 3 times 3 is 9. So we are simplifying. Now 2 minus 3 is minus 7. 2 minus 9 is minus 7 over 3. Bracket square all over 2 plus 9 is 11 over 3. Now 7 minus 7 square is 49. 3 square is 9. All over 11 over 3. So the point where we have now, we have 49 over 9 divide 11 over 3. Now if I were to turn this division sign into multiplication, we have 49 over 9 times 3 over 11. And then when you turn the division sign, it becomes, you have to reverse this one, take this one up, take the other one down. So at this point, we can cancel out 3 here 1, 3 into 9 is 3. So we are left with 49 all over 33. 49 times 1 is 49, 3 times 11 is 33. So the first part of the equation, it gave us 49 over 33 as an answer. So we're going to solve for the other part of the equation now. The other part of the equation is P operation bracket Q operation R. Remember that P is 4 operation, Q is 2 operation, R is 3. So if we should solve this, it gives us what? 4 operation. We'll solve for this part first using that formula. The formula is 2 minus 3 all square over 2 plus 3. So this is equals to 4 operation. 2 minus 3 is minus 1 square all over 2 plus 3 is 5. So this gives us 4 operation. Minus 1 square is 1 over 5. So we're going to solve for this also using the relation. And this will be what? This will give us 4 minus 1 over 5 all square over 4 plus 1 over 5. So we're using the same process again. All over 1 over 1. Now, the LCM of 1 over 5 is 5. 1 into 5 is 5. 5 times 4 is 20. Minus 5 into 5 is 1. 1 times 1 is 1. 5 into 5 is 1. 1 times 1 is 1. All over, find the LCM of 1 of 5 here. The LCM of 1 of 5 is 5. So, in this down part, we have the 1 into 5 is 5. 5 times 4 is 20 plus 1. Good. This is all of square. Now, to simplify this, we have 19 over 5 all square over 21 over 5. Okay, so what we have now here is 19 over 5 square. We have 19 over 5 square all over 21 over 5. So this is the same thing as 19 square. I think 19 square should be 361. 361 over 5 square is 25. All over 21 over 5. So we have 361 over 25 divide 21 over 5. And this is 361 over 25 times 5 over 21. If we are to turn this, take this one up, this one down, turn this 2 times. 5 here 1, 5 here 5. So we are left with 361 times 1, which is 361, over 5 times 21, which is 1 whole 5. Hence, it's not associative because the first part we have 49 over 33, and the second part we have 361 over 15. If you want to learn more about associative binary operation, you can message me directly on WhatsApp. Meanwhile, subscribe to this channel, like and share my video. Bye.